So we're given two functions here and we want to subtract them and then evaluate at -1. So first what we'll do is what is f minus g of x, and keep in mind that f minus g of x is the same as f of x minus g of x. So f of x is x squared plus 1, and we're going to subtract g of x, which is x minus 4. So that becomes x squared plus 1 minus x plus 4 by distributing the negative, which can be simplified as x squared minus x plus 5. So this is f minus g of x. But we want to know what is f minus g of -1. So now what we do is replace all our x values with -1. And if we simplify this, we have 1 plus 1 plus 5. So f minus g of -1 is equal to 7. If we look at our next problem, given f of x and g of x, we want to find the composition of f composite g of x. So what we'll do is start out by writing the function f, which is x squared minus 1, but keep in mind that this here has to be replaced with g of x. So that becomes 3 over x plus 1 quantity squared minus 1. And this could be simplified as 3 over x plus 1 times x plus 1 minus 1, which is the same as 3 over x squared plus 2x plus 1 minus 1, and finally that's 3 over x squared plus 2x, and that is f composite g of x. For part B, we're looking for g composite f of x. So once again, we'll start out by writing the function g of x in this case, g of x, which is x plus 1, but keep in mind now we'll replace the x with f of x. So this becomes 3 over x squared minus 1 plus 1. Finding common denominator for this, we have x squared minus 1, and this becomes 3 plus x squared minus 1, because this is like 1 over 1. And finally, g composite f of x could be simplified to x squared plus 2 over x squared minus 1. And then part C to this asks if f of x and g of x are inverse to each other. And we know the only way that f of x and g of x are inverse to each other is if f composite g of x is equal to g composite f of x, and that must be equal to x. But this is not true for our example. Okay, these were not true. So they are not inverse of each other. Now if f composite g of x, if this here was equal to x, and if this here was equal to x, then we would say that they are inverse, but in this case they are not inverse. Our final problem has two parts, which is f plus g of x, which is just the sum of two polynomials, because this is equal to the same as f of x plus g of x, and that becomes x over x plus 7 plus x cubed, which is like x cubed over 1. Finding the common denominator, which is x plus 7, the numerator can be written as x plus x to the 4th plus 7x cubed. Writing this in correct order, so f plus g of x is the same as x to the 4th plus 7x cubed plus x over x plus 7. And the second part of the problem is what is f divided by g of x. Now this is the same as f of x divided by g of x. So this becomes x over x plus 7, all of this divided by x cubed, which can be simplified. So x over x plus 7 divided by x cubed, which is the same as x over x plus 7 times 1 over x cubed. And this could be simplified to as 1 over x squared times x plus 7, or we can write 1 over x cubed plus 7x squared. And this is f over g of x. And this is the end of the solutions for exam number 1.